Hello everyone. Today we'll be learning about data independence, which is one of the most basic but the most important concepts of database management systems. I'm Harshita Pawar, a student from the Department of Computer Science and Information Technology at Acropolis Institute of Technology and Research. Today we'll be looking at the three schema architecture, simultaneously the three levels of abstraction, the concept of data independence, the types of data independence, and the advantages of data independence. So the first thing we'll be looking at is three schema architecture. This is the diagram of a three schema architecture. It consists of a database, a physical schema, a conceptual schema, and views, multiple views. It has three layers: physical layer, conceptual layer, and the external layout view or end users level or external layer. Now, what is data architecture? Database architecture refers to the structural design and methodology of a database system which forms the core of DBMS. Database architecture is basically the structure or the way that we are going to form the database, the whole of database. And the three schema architecture is one of the types of database architectures. The main objective of three schema architecture is to enable multiple users to access the same data with personalized view while storing the underlying data once. That is, if we are storing something in the database, we have specified everything in the database, the data types and all that. We'd have to do it just once, and there will be multiple users that will be accessing the data according to their needs or desires. That is a personalized, customized view. Now, the approach in which a particular user needs to view the data changes over time. That is, the customized view that we have created for the user must change over time with the updations that we are making in the database. An internal structure of the database should be unaffected by changes to physical aspects of the storage. That is, if all the internal structures that will be creating in the database, that is the data types of certain entities and all that, should not be affected if we change anything to the physical aspects. Now, there are three levels of abstraction in the three schema architecture. These are physical schema, conceptual schema, and external schema. The physical schema holds the memory allocations, encryption techniques, data compression techniques, and etc. Conceptual schema holds the ER model of the database, the relationships among the data. That is, the physical schema contains all the data types and the specifications about the attributes. The conceptual schema holds the whole relation and the relationships between those relations, or as we call it in the database, entities. External schema holds the schemas, the subschemas, multiple views for multiple users that will be creating. Now, the concept of data independence. Data independence revolves around the concept of three schema architecture. Now, data independence refers to the characteristic of a database of being able to modify the schema at any level of the database without altering the schema at the next or higher level. That is, if we change the data on any one particular level, that is any one particular schema, it shouldn't change the data that we have saved on the upper levels. That is, if we are changing the data type of a particular attribute, it shouldn't alter the relationships between the tables. The concept is named independence as the data between the three levels of architecture should be independent enough that modification at one level must not affect the data present in or the operations going on in the higher level of the schema. The same thing. It is called independence because the data is independent. One layer is independent of the other layer. Now, there are two types of data independence. One is physical independence and second is logical independence. Physical independence is the independence that lies between physical and the conceptual schema. And the logical independence is the independence that lies between the conceptual and the external scheme. As we can see with this diagram, that physical independence lies between the physical level and the conceptual level, and logical independence lies between the conceptual and the external level. Now, what is physical data independence? Physical data independence refers to the ability to modify internal schema without having to alter the conceptual schema. That is, the changes in the storage size must not affect the relationship between the data. As I said before, if we are altering the data type of any attribute, or we are changing the size, as we use in the database the queries like int50, the range that we give. If we are changing the range of the numbers that it can hold, the integer range that if we are changing, it should not change the relationships that we have set between two tables. That is called the physical data independence. It occurs at the logical interface. The area between the physical level and the conceptual level is also called logical interface, so it lies there. Now, what is logical data independence? Logical data independence refers to the ability to modify logical schema without having to alter the external schema. Now, suppose we are changing some relationships between the tables, or we are changing the ER diagram of the ER schema of the data. It should not affect the custom view of the user. That is, it should be independent, like it shouldn't stop working or stop the view at all. Now, that is, the changes in the relationships among the data must not affect the user view at higher level. The same thing. It occurs at user interface level. The area between the conceptual level and the external level is also called as user interface level. So, logical data independence lies there. Now, what are the advantages of data independence? As I can read it out: flexibility, application compatibility, easier maintenance, enhanced security, data continuity, scalability, data integration, reduced risk, and there are many more. Flexibility, as it provides the data flexibility. Like if we want to insert something, we wouldn't need to be conscious about it altering the data at higher levels or stopping the system at all. Application compatibility, because it would work on different applications. If there is physical data that is stored at one place and we alter it through different application, it wouldn't change the data on the next level. Easier maintenance. Maintaining here can also refer to updation and deletion anomalies, which wouldn't occur if there is data independence. Enhanced security. So if a DBA which works at the logical level is changing any relationship in the data, it wouldn't affect the higher views. So our data is secured. Data continuity, that is, data works continuously and there is a flow between the data which doesn't break even if we alter it. Scalability, we can store more data and we can give 100 number of views. We can scale our data in different views. Data integration, reduced risk. The same thing as enhanced security. It reduces risk as we wouldn't have to care about our data being altered. Thus, data independence is one of the most common but the most important concepts of database management systems. Thank you.